All right, let's dive into the super high-stakes world of pharmaceutical manufacturing.
Okay, picture a giant music festival right after the headliner finishes. Total chaos, right?
Now, what if that exact same everyone at one rush happened inside a pharma facility? The fallout is huge. Production just stops. An entire expensive batch could be ruined.
So how do you prevent this disaster? That's where the peak load study comes in.
So what is it? Think of it as the ultimate stress test for the facility's water system.
A good analogy is the city power grid on a highway, but for ultra-pure water.
And the whole goal is to prove it can handle the pressure and keep the water flowing.
Why all the fuss? Well, it's all about engineering for the absolute worst-case scenario.
There are three big reasons. First up, you've got to defend against.
See, if water sits still, it grows biofilm, and that means a complete, costly shutdown. Second, you need consistency. You can't have one area of the plant stealing all the water.
And third, well, regulators like the FDA require you to prove your system is stable.
Okay, so how in the world do you actually create this worst-case scenario on purpose?
Well, they don't just open every valve. They use a smart probability called a diverse factor.
And get this, the water has to move fast between 3 and 6 feet per second.
To juggle all these demands, the system needs a really sophisticated real-time control center.
A key part is something called a VFD. It's like the system's gas pedal, kicking instantly.
You know, it really all boils down to this. If the water system fails, there is no product.
So this study isn't just another test. It's basically the insurance policy for the whole nation.
It really makes you wonder, right? What's the biggest system crash you've ever witnessed?